Okay, so this is continuing our little series of videos on building good regression models, and we're going to look at collinearity here. And the idea is that independent variables should not be highly correlated. If independent variables are highly correlated, then this can lead to some instability in the regression estimates. Now, for those of you engineers with a matrix algebra background, this just basically means the regression matrix becomes singular and it becomes linearly dependent, and we try and invert it, and we get a bit of a mess. But for the purpose of this class, just realize you shouldn't have very high correlations between your independent variables. So let's go to the bank data. And let's select all the bank data. And we're going to do the data analysis tool pack. And this time we're going to select correlation. And actually, I'll just have to put it in the input range. There we go. And we have labels in the first row. And all this is doing is it's getting a table of correlations between the variables. So we're going to just stick it up here. And we look at these correlations. So there's a very high, as expected, a high correlation between income and wealth. So it might be a good idea only to include one of those variables in the regression. And there's going to be, and we see here that both income and wealth are highly correlated with a dependent value, which is balance, but kind of we'd only want to include one of them. Now we also see that the book recommends that we don't have correlations greater than 0.7. Now that's maybe a little bit low from my perspective, but let's just kind of stick with the book. So let's just say we've got a high correlation between wealth and income. To read this chart, just realize the chart, the lower triangle contains basically correlations between every combination of variables. A correlation between a variable and itself is 1. We don't need the upper side of the chart because correlations are symmetric, i.e. age and income is exactly the same as income and age. So to help us, let's just highlight any correlations above 0.7. And I'm going to highlight in yellow the ones between the independent variables. So we basically have 3. And less important, we've got the ones between the independents and dependents, but let's just to say these are highly correlated, let's just do these in light blue. But it's the yellows that were most important. So we only really want, one of wealth and income. We're testing, and one of income and home value, and one of education and home value. So basically we can kind of solve this if we get rid of income and home value, then we're left with age, education, and wealth. And these 3 variables don't have strong correlations with each other. It's probably going to make our regression model a little bit weaker, but it's probably, we just make sure that our independent variables are not correlated. So we basically choose age, education, and wealth. So let's build our regression model. Data analysis. Okay, so actually what we need to do first, again, as we did last time, we need to put age, education, and wealth together. So let's insert cut cell. So we've got age, wealth, education and dependent variable. Okay, so we're good to do a regression. Dependent variable doesn't change. And actually, because we picked 3 variables last time, we actually have A4 to C106. So that's perfect. Labels, and where do we want our output range? Let's just put it down here. Okay, so we see here we've got our resulting regression model. Again, our R squared is a little bit lower than the 0.94, something we had before, but none of our independent variables are correlated, and they're all 3 of them are highly significant. So that's the and the overall regression is still amazingly highly significant. Just a note, the material on page 308, there's something called a variance inflation factor. And what a variance inflation factor does is each independent variable, I create a regression with that independent variable as the dependent variable and all the other independent variables as independent variables. And I basically see how much those other variables predict this independent variable. And then I kind of, take some sort of function of R squared, and it gets the higher the R squared, then the lower the higher this thing called the variance inflation factor is, and if it's above 10, then we can decide to remove the variable. But we don't have any of those kind of features in Excel. So we just have to resort to just looking manually at the correlations, which actually, because it makes us think about things, it's not necessarily a bad thing.